Okay, here we go. We want to be able to graph piecewise functions and then be able to determine the limits. So back when I first started teaching this, I don't know, 10 years ago, whatever, we used to just kind of, throw it all together into yesterday's lesson. But that didn't really help very well. So past, I don't know, 6 years, we break it up into two pieces. Do you remember how to graph piecewise functions?
I don't know what piecewise means.
We reviewed it a little bit, right? Good. Good. So Colin is seeing right away that we've got three different graphs that are going on here. Number one, we have y is equal to 3. So if you're going to draw this, just be ready to erase it. But do you know what the graph of y equals 3 looks like? What? Horizontal line that passes through? There you have it. How about the graph of 1? Horizontal line that passes through 1. X squared plus 2. Parabola shifted up 2. So that's the first part, is can you keep that picture in your brain? Yeah? Okay. So let's sketch these graphs over the specified domain. The graph of 3 for x less than -1. -1 is where we have a break in the graph. If you plug in -1, what is the output? If I plug -1 into y equals 3, what is the y value? 3. Everybody agree the y value is always 3? Is the circle open or closed? It is open. So if I go back 1 and up 3 units, 1, 2, 3, I have an open circle. And remember, you said that the graph was a horizontal line as such. Notice that the next one says 1 for x equals -1. Can you anticipate what that's going to look like? Just a point, right? When x is equal to -1, y is 1. When x is -1, y is 1. And so it's not, there's no inequality sign here, so I don't graph all the way to the left or all the way to the right. I simply plot -1, 1. And then we have x squared plus 2 for x greater than -1. I plug in -1. And what do you get? 3. -1 squared is 1, plus 2 is 3. So remember, that was a parabola. I'll draw that in blue. There's my piecewise function. Getting a what from this corner over here? If you
So what was the -1, 3 for, though?
right here.
Yeah.
So that means that's where the end point is.
Oh, okay.
That's how I know where to end. She understands, as Aurelie smiles at her. Any questions of that? Going once, twice, 3 times. Let us now calculate the limits. It says the limit as x approaches -1 from the left. What is that limit? The limit as x approaches -1 from the right. The limit as x approaches -1 as a whole. Why is this 3? Because the left side is the same as the right side. So therefore, the limit exists at the limit is 3. F of -1. 1. So the goal that I'm trying to accomplish during this lesson is to just help you understand, again, this idea of having an open circle, a closed circle, that the limit can be different than the function value. Look at the right hand, the left hand being the same. You don't have to have a closed circle for the limit to exist. All those things. How about the limit as x approaches 0 from the left? 2. 0 from the right? Does the limit exist as a whole? It is 2. And if you plug in 0 to the function, what do you get? You get 2. So you can see in that situation, it's 2 all the way across. Look at the nice behavior of the function. Again, you have a point right here. The right is the same as the left, which is the same as the function value. That all comes together. Whereas this, you have that broken part. Notice how they are different. Okay, let's try one more. Oh no. Okay, what does e to the x look like? Henrik and Abby see it. E to the x is a graph that looks like that. Again, I'm going to erase them. I'm going to erase some of these. 1 minus x squared, what does that look like? 1 minus x squared. Parabola, that is down, flipped upside down because of the negative, and it shifted up 1 unit because it's a negative x squared plus 1. So therefore, the parabola will look something like that. What is the graph of 2? Yep. All lines are straight. This is a horizontal line that passes through 2. You know what the logarithmic function looks like? If you know the exponential function, you know the logarithmic function. The exponential function is like this. The logarithmic function is like that. Okay, it's the inverse. We'll show you one more time. Logarithmic function is like this. Okay, notice how similar it is to the exponential function. They are inverses, so they're reflected over the line y is equal to x. Can you see that? If you know one, you know the other. Thank you. So some people say to me sometimes, we don't know what a logarithm is. Well, think of an exponential and then go from there. So those are the 4 graphs. Are we all good? All right, let's go ahead and then erase these and try to come up with a great graph representing this situation. E to the x for x less than or equal to 0. Let's plug in 0. What is e to the 0? 1. Anything to the 0 power is 1. So I'm going to mark 0, 1. Open or close circle? Open. There it is. I have 1 minus x squared between 0 and 1. So I will plug in 0. What do you get when you plug in 0? 1. What do you get when you plug in 1? We get 0. So those are my 2 endpoints. Is the first one open or closed? Closed. That's fortunate, isn't it? Second one, open or closed. And remember, the graph was a parabola that looked as such. So we sketched that portion of it. How do I graph 2 for an x value of 1? How do I graph 2 for an x value of 1? It's just a point. Very good. 1, 2. That coordinate 1, 2. So I'm going to go over 1, and I will go up 2 units. Right there. And for the last one, negative 1 plus logarithm of x. Okay, we talked about what that function looked like. Let's now plug in 1. You're going to see this come up throughout the year. Let's understand what this means. The first time you do it, you'll be confused. Okay, we're going to plug in 1. What is the log of 1? We're kind of wondering what that is, right? What's log of 1? Let's write it down. Log of 1. That means, okay, it means 10 to what power is 1? That's what this means. Anything to what power is 1? 0. The log of 1 is 0. If I take out my calculator, hopefully you'll convince yourself as well. If we plug in 1, log of 1 is 0. Because that's what it means. It's normal if that doesn't work with your brain right away, but at some point we have to convince ourselves that these two expressions are the same, and that's why the log of 1 is 0. So you get 0, and then a minus 1, we get negative 1. Open or close circle? Open. And we talked about that logarithmic function heading off like that. Now, between you and your peers, go ahead and do all these limits and then check them against each other. Ready, set, go. Okay, let's check. 0 from the left. 1. From the right.
1.
The limit as a whole.
1.
F of 0.
1.
Notice how you could draw the graph without picking up your pen, right? What did you notice about all of those? They were the same. Trying to set you up for something you're going to learn as we move forward. Look at this one. Can you draw it without picking up your pencil? No. So look at what you get. 1 from the left is 0. Negative 1 does not exist. And 2. So in this case, you have all 4 that are different. Any questions on that? The first 2, yes. It says limit as x approaches 1 from the left. So I'm going to an x value of 1. If you follow the function, we're approaching this height right here, a height of 0. In this situation here, you're approaching 1 from the right. So I'm going to approach this value of 1, this x value of 1. I'm going to come this way. As you can see, you're approaching a height of negative 1. Is that better? Any other questions? Excellent question. Question going once. Twice. 3 times.